This is 5-4, solving special systems. So you've been solving systems of equations, and where the two lines meet is the solution. When two lines intersect at one point, there's exactly one solution. A system with at least one solution is a consistent system. So that's what you've been dealing with all along, are these consistent systems that have one solution. When the two lines in a system do not intersect, they are parallel lines. There are no ordered pairs that satisfy both equations, so there is no solution. A system that has no solution is an inconsistent system. So no solution, which is parallel lines, because think about it. When are parallel lines going to intersect? Because we need the point where they're going to intersect, right? They're never going to intersect. So that's why it's no solution in an inconsistent system. An independent system has exactly one solution. So again, what we've been dealing with. And a dependent system has infinitely many solutions. So what's happening there is the graph of a dependent system has two non-intersecting lines. When we have infinitely many solutions, though, that's just the same line stacked on top of each other. If you notice, all of these points are where they're intersecting. And so it's like an infinite amount of points that they're intersecting. So here we're just reiterating all of that. When you have exactly one solution, those are intersecting lines. When you have infinitely many solutions, it's coinciding lines. It's one line stacked on top of each other. When you have no solution, those are parallel lines because they're never going to intersect. So these special situations is what makes us have special systems. Okay, so this first one says that there's going to be no solution. Well, we know from the graph from before that no solution means that they have parallel lines because they're never going to intersect. And what else do we know about parallel lines? That was the old definition, that they'll never intersect. But the algebraic definition is that they have the same slope, the same m. Oops. So let's take a look at what that would look like. Our first equation's already isolated, and the slope is 1. In the second equation, when we isolate this, we're going to bring x to the other side. Oops, the other side of the equal sign. And it's going to make it positive because we'd be adding x to both sides. So this turns into y equals positive x plus 2. And so again, we have the same slope. The slope is 1. So I know for both of these that we're going to have the same slope. So in the first equation, m is 1. And it says that compare the slopes and the y-intercepts. The y-intercept is negative 1. In the second equation, our slope was 1. And our y-intercept is 2, taken from right there, the b. The y-intercept is the b, right? Okay, graph the system. So if we graph both of our equations, so our first one is y equals 1x minus 1. That means we're going to begin at the b, negative 1, and we're going to rise 1 over 1 for our slope. So up 1 over 1, up 1 over 1. And it's really helpful to write the equation there. So 1x minus 1, or just x minus 1. I'll graph the next one in red. So y equals 1x plus 2. So I'm going to begin at 2. I'm going to rise 1, run 1, rise 1, run 1, etc. And because they had the same slope, notice the lines are parallel. I could have drawn it a little bit straighter, but I think you get the idea. So that's our system graphed, and so it'd be no solution. And then also solve this algebraically. So if we have y equals 1x minus 1, and negative x plus y equals 2. Those were the two original equations. Since one of them already has y isolated, I'm going to actually just use substitution, and I'm going to substitute x minus y in the y position of the next equation. I'm going to put that x minus 1 there. I think I said that wrong. So negative x plus x minus 1 equals 2. Combine like terms. Negative x plus x cancels. So we get negative 1 equals 2, which is false. And since it's false, it's no solution. Okay, so for the next one, I know that it's infinitely many solutions because it says it is. But here's the other reasons why I know that. Once we isolate y, so I need to move, could actually just move y to the other side. In this case, since everything else is on the left, just move y over, and we end up with 2x plus 1 equals y. So if I rewrite these, the first equation is y equals 2x plus 1. The second equation, just reverse it, is y equals 2x plus 1. Notice that they're the same exact line. So when it says compare the slopes and intercepts, the slope for the first equation is 2 and the y-intercept is 1. The slope for the second equation is 2 and the y-intercept is 1. So they're the exact same equation. And so that's why we have infinitely many solutions. When we graph them, if you begin at 1, the b, and rise 2, run 1, because it's 2 over 1. And then I do that again for my second line. Let's make that one green. Begin at 2, rise 2, up 1 over 1, up 2 over 1, I'm sorry, up 2 over 1. Notice it's the same exact line. Those are called coinciding lines. Okay, and then solve the system algebraically. So if I have y equals 2x plus 1, and my other original equation was 2x minus y plus 1 equals 0. So I know that my y is 2x plus 1. So in that y spot, I'm putting 2x plus 1. But be careful, because it has something in front of it, the minus, I have to put parentheses around it. So I'm distributing that negative to both. So then I get 2x minus 2x minus 1 plus 1 equals 0. The 2x minus 2x are 0. Negative 1 plus 1 is 0. So I get 0 equals 0. Because that's true, it's infinitely many solutions. Okay, so for this next one, classify each system, give the number of solutions. So the first thing we need to do is isolate y so we can make sense of this. So in the first equation, I need to divide everything by 2. That gives me y equals, remember it's 1x, so it's like 1 over 2x plus 2 divided by 2 is 1. In the second equation, to isolate y, I need to move this negative 1/2 to the other side. It's going to become positive 1/2 x. And then a positive 1 plus 1. What do we notice? They're the same exact line, right? When we have the same line, coinciding lines, it's infinitely many solutions. Take a look at example B. Again, let's isolate y just so we can make more sense of this. Y equals 2x minus 2. And in my other equation, y equals x plus 1. So notice the slope of this one is 2, the slope of the second one is 1, so they don't have slopes in common. So therefore, there's going to be one solution, because these are going to intersect. And you can solve them algebraically. Since y equals 2x minus 2, we can just substitute that into the y position here. And when we do that, we get 2x minus 2 equals x plus 1. Bring x to the left side. We get 1x minus 2 equals 1. Add 2 to both sides, and x equals 3. And then you plug that back into the original equation. Y equals 2 times 3 minus 2. So y equals 6 minus 2, or y equals 4. Write that as an ordered pair, 3, 4. It didn't ask for the one solution, but I just wanted to show you. So if they have the same slope, they're parallel, so no solution. If they have the same slope and b, the y-intercept, same y-intercept, then they're coinciding lines, and that's infinitely many solutions. If they have different slopes, it's one solution, because they'll eventually intersect. Remember, per with equations is usually where we put our variable. So I can already see that there's going to be a variable right here, 20m. So Matt has $100 plus 20m. Ben has $80 plus 30m from the per month. Will the accounts ever have the same balance? So we have 100 plus 20m equals y, or 20x, it doesn't matter. I can write that the other way. So the total equals the total cost y. And we have y equals 80 plus 30m. And so we can try to solve by elimination. So for instance, I can make everything in the second equation multiplied by -1. And so that the y's cancel. So I get 0 equals 20. 100 plus -80 is 20. And 20 plus -30 is -10m. Bring 10m to the other side. So 10m equals 20. Divide both sides by 10. And m is 2. So in 2 months, they'll be equal to each other. And if you wanted to know what the balance will be, the total cost, you plug the 2 into one of the original equations. So y, the total in the account, will be equal to 100 plus 20 times 2. So y equals 140.